Hello and welcome back. Having discussed the basics of Newton's laws of motion and the concept of a force, it's now time to look at some specific types of forces that you will encounter in this course. First, we will talk about the four common forces that you will see a lot, which are weight, tension force, normal force, and friction. And we will also briefly talk about other kinds of forces like drag, thrust, and spring force that you may occasionally come across. So let's start our discussion with weight. As you know, weight is simply the force of attraction from the earth on an object that's at the surface of the earth or near the surface of the earth. So for example, if I have a 16-pound bowling ball sitting on the ground, its weight is simply 16 pounds. And as we discussed before, weight as a force must have units, and in this case I'm specifying the units as pounds. It's not the standard international units, which we saw was Newton, but it's a common unit that we use. It's quite similar to the SI unit of distance being meter, but in common language we talk about distance in terms of yards or miles. So pound is simply another unit of force that's not the SI unit, and there's a conversion factor between newtons and pounds, which you will get into later. Now secondly, the bowling ball did not have to be sitting on the ground for it to have that weight. If I had hung the bowling ball from a rope that's tied to the ceiling, the ball still has that weight, which is a force of attraction from the earth, which is why the rope here or the string here is kept taut. And if I toss the bowling ball in the air, it still has the weight. So weight is a long-range force, meaning that the object and the agent do not have to be in contact with each other. And you can see for weight, the object is whatever is the object of interest that we are talking about that's at or near the surface of the earth, and the agent, as we discussed before, is simply the earth. Now, since weight is a force and force is a vector, this must have directions. So let's talk about the direction of weight. Weight always points straight down. But what does down mean? Well, if we zoom out, and let's say this is the earth, and let's say you are standing here in America, and somebody else is standing here in China, that's how you'd be standing. And if I asked you which way down is, you would point this way. And if I ask your friend in China which way down is, she would point this way. So you guys are not pointing in the same direction, but both of you are pointing toward the center of the earth. So no matter where you are on earth, the weight will always point straight down, and straight down always means towards the center of the earth. Back to the normal scale, let's take a ramp here, and let's say I place a box on the ramp. Which way does its weight point? Does it point this way? Or does it point this way? One of which is going down, the other one is going down into the ramp. Since we said that the weight points directly to the center of the earth, it does not care about the angle of the floor, which is raised here as a ramp, and it'll simply point straight down to the center of the earth. So this is the right answer, and this here would be incorrect. Second, let's discuss tension force. This is a pulling force exerted on an object by a rope, wire, or string. So in the previous example where we talked about the bowling ball being hung from the ceiling by a rope, that rope is pulling back on the ball. So the ball experiences a force from the rope that's pointing in the upward direction in this case, because that's where the rope is aligned, and that force would be called tension force. And if I drag a box along the floor with the help of a rope that's tied to it in this direction, as I walk this way, what force does the box feel? Well, the box feels the tension force or pulling force from the rope, so in this case that would act in this direction. I'm going to offset the force just a little bit so it doesn't confuse it with the other line, but the tension force will act like that. So for both of these examples, the object is the ball or the box. But who is the agent? You might be tempted in this example to say that I'm the agent. After all, I'm responsible for pulling the box down the floor. But as far as the box is concerned, it's being pulled by the rope. It does not care who is on the other end of the rope. And another important fact is that of all the forces we discuss in this course, weight is the only long-range force. All the other forces are contact forces. So since I'm not in contact with the box, I can't be the agent. The agent is the rope. And the tension force is always aligned with the rope, no matter which way that points. Third, let's talk about normal force. This is the response or supporting force on an object from a surface. And unlike our common usage of the word normal, in mathematics and physics, the word normal means perpendicular. And this is useful in remembering the direction of the normal force. It is always perpendicular to the surface. So if there's a wall here and I lean into it like that, the wall applies a force on me that prevents me from falling over. And since the normal force is perpendicular to the surface and so the surface is vertical, this normal force is going to act on me in that direction. And we typically label normal force with a lowercase n so that we don't confuse it with the uppercase n, which was Newton, which was the unit of all forces. And if I take the example of a book that's placed on a sloping desk, we've already discussed that the weight points straight down, but the normal force has to act perpendicular to the surface, and since it's a supporting force, normal force in this case would act like that, where this is a 90-degree angle. The last of the main forces we will discuss here is friction. There are different types of friction which you will come to later, but as a quick introduction, let me just say that friction is the force that resists motion or resists intended motion and acts parallel to the surface. So if I have a box that's sliding down the floor in that direction, so that's the speed, the force between the surfaces that slows the box down acts in this direction. So let's call that the force of friction. And back to the example of the book that was laying on a desk, it wants to slide down, but it's being prevented from sliding down by the force of friction that acts parallel to the surfaces. So it acts like this in the upward direction because it's preventing the attempted motion down the desk. So friction is a force that opposes motion or opposes intended motion, and it always acts parallel to the surface. Finally, let me just mention the other forces you may come across in this course. They are drag. Drag is simply friction from air. You could think of it that way. So a falling object encounters drag. Bicyclists, when they race, encounter drag from the air. And then we have thrust, is the propulsion force in rockets when they expel fuel. And finally, you have spring force, where a spring comes back to its original state. So a stretched string wants to pull itself back in, while a compressed spring wants to push itself back out. So in this slice of physics, we have discussed the various types of forces that we will encounter in this course, paying special attention to the object and agent in these cases, preparing ourselves for identifying the forces that act on an object, which is our next step.